Okay, so we're back to do the rest of lesson 2.7. So let me go ahead and share my screen and get back to the textbook PDF. All right, so we have this problem situation number 2 here, understanding trends in the data. And we have this graph. As always, we want to kind of acclimate ourselves to what is being shown on this graph. So we have median and average sales prices of new homes sold in the United States. This is annual data from 1963 to 2014. So for each year, they figured out the median sale price of new homes and the average sale price of new homes. And we can see that there are 2 lines here on the graph. The blue line is the median price and the orange line is the average price. The y-axis here, the vertical axis, is price in dollars. You know, sometimes we've seen things where it's thousands of pounds or thousands of dollars or whatever. It's just plain dollars here. So we go from 0 up to $350,000. And then the years go from 1963 up to 2014. So if we look at this for a minute, let's just think about kind of what's happening here. We have 2 different values. We know that median and average or mean are both measures of central tendency. They kind of talk about what's happening in the data. In general, you can see that they follow each other here. When one goes up, and generally the other one goes up also. So new home prices obviously have risen between 1963 and 2014. That's not a surprise. And so in 1963, they were maybe $20,000 roughly. In 2014, the average price was around $330,000. And the median price was, let's see, maybe $275,000, somewhere around there. So there's a trend here. They're both going up. They've had some dips. If you remember, if you were a little older and you remember this, or if you were younger, you might have heard people talking about kind of the recession in here, the housing bubble, market broke here. So, you know, housing prices got very high. There was a lot of lending to people that maybe couldn't afford that much for a house, and then things kind of crashed in here. So that's what was happening there, and then they're going back up. So let's take a look here at some of this. So examine the graph and write at least 3 statements about the data. Recall the writing principle, use specific and complete information. So for this one, you can pick what 3 things you write about the data, okay? It can be as simple as, in 1975, the average price for a new home in the United States was approximately such and such an amount, okay? Remember that writing principle though. And what I like to say about that is that you should have a complete thought, a complete statement in your sentence. So the writing principle says we should have a complete sentence and also information such as a year or amount or where we're talking about. So a complete well-written statement here would not be, in 1984, the average price was $100,000. Okay, well, average price of what? Where, right? We want to say for new homes in the United States. So we want to make sure we have information in there. You can have some statements about a specific year and what either one of these is. You could have a statement such as, in 1999, the average price of new homes in the US was about so many dollars more than the median price of new homes in the US, okay? You could say something like, between 1990 and 1999, the median price of new homes sold in the US rose by however many dollars. So you have a lot of choices there. There's not just one right answer, but you want to write something that, again, is a complete statement. If I read just that statement, I would have an idea of what's happening here. I would know where, I would know when, I would know how much. So go ahead and pause the video and practice writing some statements there about the sale prices of new homes. Okay, so now we're back. Hopefully you had a chance to write those specific and complete information. And if you have a question about whether it's a good statement, you can always email me or send it to me in Teams, and I'll be happy to look at it, okay? All right, so table 1 here gives some sample data of home prices that matches the data shown in the graph for the year 1977. So we look at this, some sample prices might be between $35,000 and $77,500. There are 7 values here. I counted them before. You can just count them. That means there's an odd number. So this middle number right here is going to be the median. Okay, there's just one number there that will be the median because there are an odd number of data values. So there's my median. So let's take a look at the graph for a minute. So it says there the median is 48.8. So 1975, these aren't split up the most perfect way here, but 1977, sorry, is right around here. We can see that, yes, the median is right just under 50,000. And then we can see that here the average is slightly higher than the median. And if we added these up and found the mean, it would be just a little bit higher than the median. So now down here in table 2, there are 5 possible data sets for 2005. And the question up here asks you to answer the following questions without calculating the mean. So if I look down here, each of these also has 7 data points. So we can think that this row right here is our row that's going to be the median. So we can read the median right off of there, okay? That's kind of a good place to start. What we're trying to do is figure out which of these data sets, and there's more than one, there are gonna be 2 of them, could possibly be the data set for 2005. So we know from the graph, we have a median and a mean for 2005. We wanna know which of these data sets would be able to be an example of that, okay? So I'm gonna let you take a minute to look at that. This goes with down here, which of the data sets could represent the data in the graph? There's 2 of them. Which of the data sets would likely have a mean that is less than the median? And which of the data sets would likely have a mean and a median that are close together? So I'm gonna let you figure that out and work on that in just a minute. If it were me, since the median is very easy to read, I would start with the median, see which of those could be the median for 2005 here, and then take a look at the other values and what they would have to be to find an average. So before I let you do that, let me just talk about one thing here. So we notice that in most of these cases, either the average is very close to the median or the average is higher. So why is that? Well, let's say we have a median at some year of $100,000 for our new home prices, right? So the median is going to be $100,000. And we know for this, we have lots and lots of data points, right? But let's just pretend again that we have 5 data points for this. So here's my median. I know these need to be from smallest to largest. If you think about this, what's happening here, just physically in this context, the lowest possible value this could be is 0, right? And then really you can't buy a new house for $0, but let's just kind of think of that, as we can't have negative, we can't go down. So we can only go down a certain amount. What's the most you could spend for a new house? Well, maybe rephrase the question. Maybe not you and I, but what's the most someone could pay for a new house? Well, you're hearing about celebrities that pay $800,000, $900,000, $2.4 million. So really, realistically, there's no end to how far the mean can, how far the highest numbers can go. So those are going to pull the mean up in general, okay? Not always, and obviously not for every situation, okay? So, but think about what's on each side of the median pulls the mean one way or another. So if we have, let's say someone pays $10,000 for their house and someone else pays $40,000, and then we have $100,000, and then we have $1 million and $1.2 million. Well, these are so much higher than the median, and these are not that much lower, that the mean is going to be way up here, right? So in this case, the mean, is going to look a little skewed. We're going to say that the mean is, I don't know, like $900,000 or something. Well, that's really, if you just look at that, you would think, oh, that's a really rich neighborhood, but we really have a very broad value here. Okay, another example might be that if we have, in this case, the mean would be above the median. If we had that $10,000 still, let's say, and then $40,000. And then these were both 100,000 also. Because this side, the larger side, is not larger than this, or even if it were slightly larger, and these go down quite a ways, now my mean is going to get pulled down. Okay, but in general, in that graph we saw, for new home prices, the mean, we can see the average is above the median because those numbers can really go as high as we want them to, right? So that's kind of why that happens. All right, so then let me go back to this. So what I would like you to do is just pause the video and answer these 3 questions, and then we'll be done. Okay, so go ahead and pause it. When you come back, I'll just give you the answers for those, and then you'll be done with this lesson. Okay, so hopefully you did those. I'm just gonna write in here. So the data sets that could represent the data in the graph are B and E. So let's see why. So if we look at the median is 240. So this was too high with the median, this was much too low. So right away, we're kind of looking at those 3 right away. Now, if we look up here at the average in 2005, so here's the median right here, and then the average is way up here. The average is almost 300,000, so maybe like around 280,000, maybe. K means 1,000. Okay. So roughly something like that. So we know that we have the 240 for the median. We know we want to have something around 280,000. Oops, not 300. 280,000 for the mean or the average. So what we want to do is we want to look for values that will give us about 280,000. So if I look at set D, the reason I can take that out right away is because if I look at this, not one value there is above 251,000. So there's no way that my mean can be 280,000. I need some really large values to pull that mean up. So this one, because of this, this is like saying I got 30s on all my tests and I'm hoping my average is a 50. Okay, it's not going to happen because nothing's that high. So that's why B and E, both, if you look at them, they have some larger values there that are going to pull that mean up. Okay, which of the data sets would likely have a mean that is less than the median? So that's going to be that D that we just talked about, right? The median is 240. Almost everything is below that or very slightly above it. And which would have a mean and a median that are close together? That's going to be set A. If you look at this, these values are very close together. So this is only about 13,000 below. This is about 20,000 above. I mean, they're very close. So the mean and the median are both going to be right in that area there. Even if they weren't close together, if they were just sort of symmetrical on both sides in terms of how far spread out they were, that would also make that mean and median close together. Okay, so hopefully that works for you to get through lesson 2.7. And I'm going to stop this and upload it. Thanks, guys.